organic compounds, the elements such as carbon, hydrogen and oxygen are assumed to be present. Elements other than these may also be present in organic compounds. These extra elements are usually detected by a general test known as Lassaigne's test or the sodium fusion test. In this test, the organic compound is fused with sodium metal. Any halogens, nitrogen and sulfur will be converted into inorganic sodium salts such as sodium halide, sodium cyanide and sodium sulphide. The ionic compounds formed during fusion are extracted in ionic solution and the extract is called sodium fusion extract or Lassaigne's extract. Our aim here is to prepare the Lassaigne's extract of the given organic compound. Materials required: sodium metal, distilled water, organic compound, forceps, fusion tubes, test tube, tongs, dropper, china dish, funnel, filter paper, wire gauze, tripod stand and Bunsen burner. Procedure: take a small piece of sodium metal using a forceps and place it on a filter paper. Dry the sodium metal by pressing it between the folds of the filter paper. Now, take a fusion tube and put the dry piece of sodium into it using the forceps. Hold the fusion tube with the tongs. Heat the fusion tube containing sodium slightly on the Bunsen burner. Upon heating, the sodium melts into a shining globule. To this, add a little of the organic compound using the dropper. Heat it slowly to start with, so that the compound reacts with the sodium metal. Next, heat the tube strongly till it becomes red hot. Plunge the red hot tube into the china dish containing a small amount of distilled water. Now, heat the contents of the china dish over the Bunsen burner until the volume of the solution is reduced to 1/3 of its initial volume. Filter the solution into the test tube using the funnel and the filter paper. The filtrate is called Lassaigne's extract. Precautions: always use forceps while handling sodium metal because it is highly reactive. Before using sodium, press it within the folds of the filter paper to dry it. Use dry fusion tube for sodium fusion. Repeat the process of sodium fusion with 2 or 3 ignition tubes to ensure that fusion has taken place. Use a small amount of distilled water for Lassaigne's extracts preparation. Detection of nitrogen in an organic compound. There are many organic compounds such as amines, amides, nitro compounds and urea containing nitrogen as one of the main elements. Nitrogen is covalently bonded to the organic compound. Upon fusion with sodium metal, the covalently bonded nitrogen is converted to ionic sodium cyanide, which can be extracted by boiling the fused mass with distilled water. Ionic sodium cyanide is used for the detection of nitrogen. Our aim here is to detect the presence of nitrogen in an organic compound. Materials required: Lassaigne's extract, freshly prepared ferrous sulfate solution, ferric chloride solution, concentrated hydrochloric acid, test tubes, test tube holder, droppers and Bunsen burner. Procedure: take a small portion of the Lassaigne's extract in a test tube. To this, add a small quantity of freshly prepared ferrous sulfate solution. Sodium cyanide formed during fusion reacts with ferrous ions to form sodium ferrocyanide. Heat the contents of the test tube over the Bunsen burner. Next, add a few drops of ferric chloride solution using a dropper. Using another dropper, add concentrated hydrochloric acid to acidify the contents of the test tube. The sodium ferrocyanide reacts with ferric chloride to form a Prussian blue or blue-green colored ferric ferrocyanide. Precautions: handle the apparatus and chemicals carefully. Use freshly prepared ferrous sulfate solution. Use droppers to take reagents from the bottles. Detection of sulfur in an organic compound. Sulfur is a non-metallic chemical element with the symbol S. It is present in many organic compounds such as thiol and carbon disulphide. The antibiotic penicillin and the artificial sweetener saccharin are also sulfur-containing organic compounds. Upon fusion with sodium metal, the sulfur atom in the organic compound is converted to ionic sodium sulfide. The ionic sodium sulfide can be extracted by boiling the fused mass with distilled water and is used for the detection of sulfur. Our aim here is to detect the presence of sulfur in an organic compound. There are two tests to detect the presence of sulfur. They are sodium nitroprusside test, lead acetate test. Sodium nitroprusside test. Materials required: Lassaigne's extract, sodium nitroprusside solution, test tube and dropper. Procedure: take a small portion of Lassaigne's extract in a test tube. To this, add a few drops of sodium nitroprusside solution using a dropper. Sodium sulfide formed during fusion reacts with sodium nitroprusside to form a purple-colored sodium thionitroprusside. Lead acetate test. Materials required: Lassaigne's extract, acetic acid, lead acetate solution, test tube and droppers. Procedure: take a small portion of Lassaigne's extract in a test tube. Using a dropper, add a few drops of acetic acid to acidify the Lassaigne's extract. Now, add a few drops of lead acetate solution using another dropper. Sodium sulfide formed during fusion reacts with lead acetate to yield black precipitate of lead sulfide. Of halogens in an organic compound. There are many organic compounds containing halogens such as fluorine, chlorine, bromine, and iodine. They are called organohalogen compounds. Some commonly known examples are carbon tetrachloride, chlorofluorocarbons, DDT, iodomethane, and bromobenzene. Upon fusion with sodium metal, the halogens in the organic compound are converted to ionic sodium halides. Ionic sodium halides can be extracted by boiling the fused mass with distilled water and are used for the detection of halides. Our aim here is to detect the presence of halogens in an organic compound. There are two tests to detect the presence of halogens. They are silver nitrate test, carbon disulphide test. Silver nitrate test. Materials required: Lassaigne extract, concentrated nitric acid, silver nitrate solution, ammonium hydroxide solution, test tube, droppers, test tube holder, and Bunsen burner. Procedure: take a small portion of Lassaigne extract in a test tube. To this, add a small amount of concentrated nitric acid using a dropper. Boil the contents of the test tube over a Bunsen burner and cool. Using another dropper, add silver nitrate solution to the test tube. If the organic compound contains chlorine, the sodium chloride formed during fusion reacts with silver nitrate to form a white precipitate of silver chloride. If the organic compound contains bromine, the sodium bromide formed during fusion reacts with silver nitrate to form a pale yellow precipitate of silver bromide. If the organic compound contains iodine, the sodium iodide formed during fusion reacts with silver nitrate to form a yellow precipitate of silver iodide. Now, using another dropper, add the excess of ammonium hydroxide to the precipitates. Silver chloride is soluble in ammonium hydroxide. Silver bromide is sparingly soluble in ammonium hydroxide. Silver iodide is insoluble in ammonium hydroxide. Carbon disulphide test. Materials required: Lassaigne extract, dilute hydrochloric acid, carbon disulphide, chlorine water, test tube, and droppers. Procedure: take a small portion of Lassaigne extract in a test tube. Using a dropper, add a small amount of dilute hydrochloric acid to acidify the Lassaigne extract. Using another dropper, add a small amount of carbon disulphide to the test tube. Carbon disulphide forms a separate layer above the Lassaigne extract. Now, add freshly prepared chlorine water using another dropper and shake the test tube vigorously. If the organic compound contains bromine, the sodium bromide formed during fusion is oxidized to bromine, which is dissolved in carbon disulphide and imparts orange color to the carbon disulphide layer. If the organic compound contains iodine, the sodium iodide formed during fusion is oxidized to iodine, which is dissolved in carbon disulphide and imparts a violet color to the carbon disulphide layer. Precautions: handle the apparatus and chemicals carefully. Use droppers to take reagents from the bottles.